Human beings are obsessed with beginnings. Every story we tell has a first chapter. Every physical object we interact with was built, grown, or formed at a specific moment. Our brains are hardwired by evolution to understand cause and effect. Yesterday causes today. So, when we look up at the night sky and observe the expanding cosmos, our natural instinct is to rewind the clock. If the universe is expanding outward today, then in the past it must have been smaller, denser, and hotter. If we run that cosmic clock backward far enough, the math tells us that everything in the observable universe, every galaxy, every star, every atom, and every photon, was squeezed into a single, infinitely dense, infinitely hot point, a singularity. Based on the most precise measurements of the cosmic microwave background and the expansion rate of space, we know exactly when this happened. Our universe sprang into existence roughly 13,800,000,000 years ago. We call this moment the Big Bang. It is the ultimate origin story. But the moment you accept the Big Bang, an inescapable, agonizing question immediately forms in your mind. A question that has kept the greatest physicists, philosophers, and theologians awake at night. What happened before? What triggered the explosion? What space did the universe expand into? If nothing comes from nothing, how did everything come from nothing? For a very long time, scientists simply refused to answer this question. They argued that the question itself was fundamentally flawed. To understand why, we have to look at the work of Albert Einstein and his theory of general relativity. Einstein proved that space and time are not separate things. They are woven together into a single fabric called space-time. And the shape of space-time is determined by gravity and mass. At the moment of the Big Bang Singularity, the mass was infinite and the gravity was infinite. Therefore, the curvature of space-time was also infinite. In physics, when numbers hit infinity, the equations simply break down. The laws of physics, as we understand them, cease to exist. According to the classic model, the Big Bang was not just the beginning of space. It was the absolute beginning of time. Time itself was created in that explosion. Therefore, asking what happened before the Big Bang is a logical paradox. The legendary physicist Stephen Hawking popularized a brilliant analogy for this. He called it the no-boundary proposal. He argued that asking what happened before the Big Bang is like asking what lies north of the North Pole. Once you reach the absolute North Pole, the concept of north simply loses all meaning. Every direction is south. In the same way, at the moment of the Big Bang, the concept of before loses all meaning. There's no time outside of our universe to measure it against. For a while, that was the standard scientific answer, but let's be honest, it is a deeply unsatisfying answer. Our minds rebel against the idea of a true beginning without a cause. Fortunately, theoretical physics has advanced significantly since the classic Big Bang model was established. General relativity is brilliant at describing the massive scale of stars and galaxies, but it fails completely when trying to describe the microscopic, quantum world. To truly understand the singularity, we need a theory that marries gravity with quantum mechanics. And while we don't have a perfect theory of everything yet, the attempts to create one have given us some mind-bending theories about what existed before our universe began. Let's explore the 4 leading theories. Theory number 1 the Big Bounce. What if our universe is not a one-time event? What if it is just the latest breath in an eternal cosmic respiratory system? This idea comes from a field of physics known as loop quantum gravity. This theory suggests that space is not a smooth, continuous fabric. Instead, if you zoom in close enough, space is pixelated. It is made of tiny, indivisible loops of quantum energy. Because space has a minimum possible size, known as the Planck length, matter cannot be compressed infinitely. A true singularity is impossible. So, what happens if you have a universe that stops expanding, reverses course, and begins to collapse under its own gravity? A process often called the Big Crunch. The galaxies rush toward each other, the stars are crushed, and all matter is squeezed into a microscopic space. But because space is pixelated, it can only be squeezed so far. Once it reaches its maximum quantum density, the immense repulsive forces at the quantum level push back. The Big Bounce. The collapsing universe violently rebounds, exploding outward in a massive expansion. A big bounce. In this model, there is no absolute beginning of time. Before our Big Bang, there was a previous universe that collapsed. And before that, another one. A continuous, infinite chain of universes expanding and contracting, dying and being reborn, stretching back into an eternal past and forward into an eternal future. We just happen to be living in the current iteration. Theory number 2. Eternal inflation and the multiverse. To solve some of the mathematical problems with the Big Bang, cosmologists proposed the theory of cosmic inflation. This theory suggests that in the first tiny fraction of a second, space expanded at an unimaginably rapid rate, faster than the speed of light. This inflation smoothed out the universe and set the stage for stars and galaxies to form. But here is the catch. Quantum mechanics dictates that this inflating field of energy wouldn't just stop everywhere all at once. Eternal inflation. Instead, inflation is constantly happening somewhere in the vast underlying fabric of reality. It is eternal. Think of this underlying reality as a giant ocean of boiling water. The bubbles that form and expand in the boiling water are individual universes. In this scenario, our Big Bang was simply the moment when inflation stopped in our specific localized bubble. But outside our bubble, the eternal ocean of inflation continues to boil, constantly spawning billions of other bubble universes. Each of these universes might have entirely different laws of physics, different dimensions, and different fundamental forces. So, before our Big Bang, there was, and still is, a rapidly expanding infinite multiverse, generating endless realities. Theory number 3. The collision of branes. If you want to get truly strange, we have to look at string theory, or more specifically, M theory. String theory suggests that the fundamental ingredients of reality are not tiny dots of matter, but vibrating strings of energy. But for the math of string theory to work, the universe cannot just have the 3 dimensions of space and 1 dimension of time that we experience. It requires 11 dimensions. Because we cannot perceive these extra dimensions, physicists suggest they are folded up, microscopic, or take in the form of vast, invisible membranes. They call these membranes branes. According to the ekpyrotic model, which comes from the Greek word for cosmic fire, our entire 3-dimensional observable universe exists on one of these colossal branes, floating through a higher dimensional space. Imagine two massive flat bed sheets hanging parallel to each other on a clothesline, rippling gently in the wind. These bed sheets represent two separate branes, two separate universes, completely empty and cold, hovering extremely close to one another in higher dimensional space. Over trillions of years, the gravitational attraction between these two branes pulls them closer and closer. Eventually, they collide. Brane collision. The kinetic energy of this massive multidimensional collision is instantly converted into matter, radiation, and immense heat across the entire surface of the branes. To anyone living inside one of those branes, that colossal impact would look exactly like a Big Bang. The branes then bounce apart, slowly cooling down and expanding over billions of years, forming stars and galaxies, exactly like our universe is doing right now. Eventually, they will cool completely, stop moving apart, and gravity will slowly pull them back together for another collision. Theory number 4, the holographic universe and the mirage of time. Finally, we must consider the possibility that our fundamental understanding of time is just an illusion generated by quantum entanglement. Some physicists studying the holographic principle argue that the universe is essentially a three-dimensional projection of information encoded on a two-dimensional surface. In this framework, the Big Bang wasn't an explosion in space, but a phase transition of information. Think of water freezing into ice. The water doesn't explode, its fundamental structure simply changes state. Before the Big Bang, the universe might have existed in a state of timeless, spaceless quantum information. There was no before because time as a variable had not yet emerged from the quantum state. The Big Bang was simply the moment the universe froze into a state where time and space became recognizable properties. We are living inside the quantum hologram. We may never know for certain which of these theories is correct. We cannot send a probe back to the beginning of time. We cannot look past the cosmic microwave background because the early universe was filled with a dense, opaque plasma that blocks all light. But humanity has a remarkable habit of making the impossible possible. Telescopes like James Webb are currently looking further back in time than ever before, observing galaxies that formed just a few 100 million years after the singularity. In the future, we might detect primordial gravitational waves, ripples in the fabric of space-time itself, that carry the echoes of the actual Big Bang, or perhaps even the collision of branes. Until then, the question remains the ultimate frontier of human knowledge. Whether we are a single bubble in a boiling multiverse, an endless cycle of cosmic breaths, or a byproduct of colliding dimensions, one thing is certain. Our universe has a deep, complex history, and the Big Bang was likely not the true beginning, but merely a spectacular transition. Thank you for exploring the edge of time with me. If you found your mind expanding, leave a like and subscribe to the channel for more journeys into the deepest mysteries of the cosmos. Keep asking questions and keep looking up.